In this video, we're going to learn how to graph ratios. For our vocabulary, we have two really new words. So the first one is continuous. This is going to make more sense as the video goes on. A continuous relationship is one that holds true at all the in-between or fractional values. So something where it's okay to break up the different pieces and that still the relationship still works. It makes sense to be able to break it up. A discrete relationship is one that only works for specific values. For example, something is discrete if you're counting people, if you're counting animals, things that can't be broken up. You can't have half a person. You can't have a third of an animal. A continuous relationship might be one that works with money because you can break dollars down into cents, right? Or it might be something that works with measurements like cups or ounces or pounds. You can have half a pound. You can have a quarter of something. So let's say weight or volume. Lots and lots of other examples. We'll think about this more. Before you move on, try and think of one other example of something that might be continuous and something that might be discrete, and add it to our list. Okay, so our first example, we're going to say that there is one dog for every 3 cats. That is a ratio, right? That's what this video is all about. We have one dog for 3 cats. That's a ratio of 1 to 3. Now, before we move on, let's think, is this continuous or is this discrete? I think that this is discrete because dogs and cats can't be meaningfully broken down into smaller parts, right? You can't cut a dog in half. Okay, so we have our ratio of 1 to 3. We're now going to make a table from that ratio. That's our first step in making a graph, is to make a table. And I'm just going to pick some data values. I'm going to start with 1, 2, 3, 4. And then if I had 1 dog, that would mean that I would have 3 cats. That's what my ratio says. If I have 2 dogs, then I would have 6, 3 would be 9, 4 would be 12. We know this, we learned this in our last unit. But now we need to translate this to a graph. So start with 2 really nice straight lines that exactly follow the grid on your notebook paper. And then we need to label our axes. One of them is going to be dogs, one's going to be cats. Let's start by doing X and Y, because that's always a good reminder. And then I'm going to put dogs down on the x-axis. Sometimes it matters which one's which. In this case, it doesn't seem like it does, but since we said dogs first, then I'll just put dogs on the X. And then we'll put cats on the Y. Okay, now we need to label our values. So I'm just going to count by ones for both axes this time. So when I label my x-axis, I get to 4, and I have a feeling that might be all I need because that's all that's in the table for dogs, but I'll keep numbering it just because I made it that big, or I could go back and erase the fact that I made my line too long, but it's okay, no harm in leaving it. But I do want to number it if I drew it, either number it or erase it. And then for cats, I'm still going to number by ones because that's what I feel like doing this time. And wow, I just barely made it up to 12. That's good because I know that 12 is the biggest number I'm going to have to get to for my cats. And so now I need to turn each of these data values into points. So when there's 1 dog to 3 cats, that can be written as 1 to 3. And then I graph that point as over 1 up 3. When there's 2 to 6, that would be graphed as 2, 6. So that's over 2 up 6. 3 to 9 would be 3, 9. And so on. Like so. Notice how all these points look beautifully lined up. Now, do you think I should connect the points? Did you say no because this is a discrete relationship? That's what I think. I think that if we were to try and plot those in-between points, if we were to draw that line in like that, that would imply that we could have 1 dog and 1.5 cats, but that wouldn't make sense, right? So we aren't going to draw that line in at all. We're going to leave the points as they are because this is a discrete relationship. I almost forgot, there's one very more important thing, that you always have to have a title for your graph. So in this case, we don't know a whole lot about the situation, so let's just call it ratio of, and we're going to say dogs to cats, because that's the order we graphed it on, the X first, of dogs to cats. Discrete means not connected. All right, this time let's think about the relationship between 2 cups per pint, like if you were measuring milk or some other liquid. This is just a ratio that always holds true. We measure pints in terms of cups. There's 2 cups per pint. Go ahead and make the table and the graph now. Does your table look like this? Don't worry about it if you reverse the cups and the pints. It doesn't make any difference either way. Sometimes it does, but not in this case. And now if you're ready to do your graph, we need to think about what sort of scale we want to use. And I'm going to continue just using a scale of 1 for these. If you're tempted to count the cups by 2, I understand. I'd rather you don't do it because it can lead people to want to just label the axis by the numbers in the table, which is not correct. Okay, you don't want to get into that bad habit. All right, so you have your graph labeled, being very careful to make sure the numbers end up on the lines and not the spaces. Now it's time to plot our points. So 2 cups to 1 pint, that's 2, 1, and so on. Notice that I'm always making sure to put the coordinates in the same order, and I'm putting the one in the first column into the first spot in my pair. It's sort of like keeping them in the same order as they are in my table. Great. And so now we need to decide. Oh, well, actually first let's title it. So in this one, we could title this the ratio of cups to pints. And then we need to decide whether we are going to connect the points or not. So in this case, is it possible to have, let's say, 5 cups being equal to 2.5 pints? Yeah, I absolutely think that works. In fact, you could have a 1/8 of a cup be equal to a 1/16 of a pint, right? Some tiny, tiny little value way over here. That would work too. Any of these in-between values, they might be hard to measure, but they work. So now we're going to connect our values into one nice, really beautifully straight line. You probably want to use a ruler for it. And then once we have that beautifully straight line, we could even use it to make predictions. So we could say that, I wonder if I had 13 cups. How many pints would that be? I could go up to 13, and then I could go over, and I could see, oh, that's about 6.5 pints. This is a continuous relationship because we can connect the points on the line. Continuous means points connected. And all right, now it's time for your practice problem. So here we're going to use the ratio that in soccer you score 1 point per goal. So for every 1 goal you score 1 point. And I need you to make a table and a graph and think carefully about whether your graph should be continuous or discrete.